Welcome. I am Jaya Nirmala, Associate Professor in the Department of Computer Science and Engineering at NIT Trichy. The co-PE of the project is Dr. N.L. Sajikumar, Associate Professor at Government Law College, Thiruvananthapuram. We have prepared the subtitles for this video in Tamil and Malayalam and incorporated in it. Please explore that feature too. We are pleased to present the progress of the research project Predictive Coding for the Identification of Ratio Decidendi in Indian Judicial Decisions, which focuses on developing AI-based methods for legal text analysis, particularly for identifying legal reasoning from Indian judicial documents. Legal practitioners often spend significant time analyzing large volumes of legal documents to identify important information. One of the most critical elements is the ratio decidendi, the legal principle or reasoning that forms the basis of the court's decision. To address this challenge, my research explores the use of artificial intelligence and natural language processing techniques to automatically identify legal reasoning from judicial decisions. So the research is organized into three major objectives: dataset creation, sentence boundary reduction in legal text, and identification of ratio decidendi from legal judgments. The first objective is to create a high quality legal dataset through collection, pre-processing, annotation, and augmentation of judicial documents. The second objective is to develop an automated system for sentence boundary reduction in legal text, which serves as an essential pre-processing step for legal NLP applications. The third objective is to identify ratio decidendi, core legal principles behind a court's decision, using advanced AI and natural language processing techniques. The focus of the first year was sentence boundary reduction in legal documents. Although sentence segmentation appears to be a simple task, it is challenging in legal text because of long sentences, legal citations, abbreviations, and irregular punctuation patterns. To address this problem, we developed a deep learning based approach, including a CNN model and a hybrid CNN CRF architecture. The CNN extracts contextual information around the potential sentence boundaries, while the CRF layer captures dependencies between the neighboring labels, resulting in more consistent predictions. Accurate sentence boundary detection is a critical pre-processing step for legal NLP applications, as it directly impacts downstream tasks such as legal summarization, information extraction, rhetorical role classification, and legal reasoning analysis. This slide presents a performance evolution of the proposed sentence boundary reduction models. The proposed CNN-CRF hybrid model achieved the best performance with an F1 score of 93.6%, demonstrating the effectiveness of combining CNN-based contextual feature extraction with CRF-based sequence modeling. The model also outperformed widely used sentence segmentation tools, highlighting the need for specialized approaches for pre-processing complex legal documents. The second year focused on identifying ratio decidendi, which refers to the legal principle or reasoning that forms the basis of a judicial decision. Automatically identifying ratio decidendi is valuable because it can assist lawyers, judges, and researchers in quickly locating important legal reasoning, thereby improving legal research and decision making. For this task, we have developed a framework that begins with in legal bird. It generates contextual representations of sentences from legal judgments. A prototype-aware learning module and BLSTM layer are then used to improve rhetorical role classification and address class imbalance by capturing important legal reasoning patterns. To enhance efficiency, LoRa-based parameter efficient fine-tuning is incorporated, reducing computational cost while maintaining high performance. By combining contextual legal understanding, prototype guided learning, and efficient fine-tuning, the framework effectively identifies ratio decidendi from complex legal judgments. This slide presents a performance of the proposed framework for identifying ratio decidendi on the Bill Nyai Indian dataset and the UK Supreme Court dataset. The proposed dynamic layer ranking fifth approach achieved the best performance across both the dataset, improving minority role recognition while requiring only a small fraction of the trainable parameters. These results demonstrate the effectiveness of the imbalance-aware, parameter-efficient fine-tuning for legal rhetorical role classification and ratio decidendi identification. Third year focuses on creating larger and higher quality legal datasets. A major challenge in legal AI is the lack of sufficiently large annotated datasets. Manual annotation is expensive and requires legal expertise. To overcome this limitation, we proposed a semi-supervised data augmentation framework that utilizes large language models to generate additional training examples and improve the performance. Multiple evaluation strategies are employed to compare the performance of the models trained with and without augmented data. This framework reduces the need for costly manual annotation by enabling scalable, high-quality legal dataset creation while enabling model performance and supporting future NLP legal research. This slide highlights the key impacts and significance of the proposed research. The research advances legal AI by introducing intelligent methods for identifying legal reasoning from judicial decisions. It supports efficient legal research by helping legal professionals quickly locate important legal principles and judicial reasoning. The work also contributes to the creation of high-quality legal datasets which can support future legal NLP research. In addition, it promotes explainable AI for law by providing transparent and interpretable identification of legal reasoning. The proposed framework further supports the digital justice ecosystem through applications such as e-courts, legal analytics, intelligent legal search, and decision support systems. This slide summarizes the key achievements of the project. Major contributions include the development of a hybrid CNN-CRF model for sentence mode reduction in legal documents and in-legal word-based frameworks for identifying ratio decidendi and rhetorical rules. We have developed and validated imbalance-aware PIF methods that improve the performance while reducing computational cost across the Indian and the UK legal datasets. In addition, semi-supervised data augmentation strategies are being developed to create high-quality datasets. These contributions resulted in the publication in the Journals of Artificial Intelligence and Law, Neural Processing Letters, ACM Computing Frontiers Conference, the NLP for Empowering Justice workshop, and the IEEE International Conference on Augmented Intelligence and Sustainable Systems. Here are the members of the research team at NIT Trichy. My acknowledgements to the ANRF for the grant and the Thiruvananthapuram Law College students for helping out in the annotation of the Indian legal judgments. Thank you.